In this video, we want to take a look at the last example for finding surface area generated by rotating a function, in this case about the y-axis. So the really big thing to catch here is that when we go around the y-axis, we want our integral to be in terms of y. So it's going to be 2 pi, the integral from c to d, where c and d are on the y-axis, of our function in terms of y, the square root of 1 plus our derivative of y squared dy. Right now, everything we have given to us is in terms of x. So we need to switch everything over into terms of y and then apply this formula. First, getting this function of y equals 3x to the 1/3 into terms of y, we can cube both sides to get y cubed equals 3 to the x, or y cubed over 3 is equal to x. So our function g of y is y cubed over 3. And also switching our bounds into terms of y, it's in terms of x. We're just going to plug in these bounds of 0 and our bound of 8/3 into our equation. So we'd have y equals 3 times 0 to the 1/3, which is 0. So our lower bound is going to stay 0. And we have y equals 3 times 8/3 to the 1/3. 3 times 1/3 is just 1, so they cancel. We're looking at the cube root of 8, which is 2. So our new bounds are 0, less than or equal to y is less than or equal to 2. There's our bounds. Back to our function, we want to find the derivative and square it. So the derivative of this function is y squared, and squaring y squared is y to the 4th. So plugging all of this information into our integral formula, we get 2 pi from 0 to 2, our bounds in terms of y, times y cubed over 3 times the square root of 1 plus y to the 4th dy. Plugging in our derivative squared and our function into those places. Evaluating this integral, I'm going to pull this 3 all the way out to have 2 pi over 3, the integral from 0 to 2, of y cubed square root of 1 plus y to the 4th dy. Now, this example may look similar to one we have worked in a previous section, where if I take the derivative of 1 plus y to the 4th, I get 4y cubed. So we're going to do a u sub where u equals 1 plus y to the 4th, and du equals 4y cubed dy, or 1/4 du is y cubed dy. So this piece is going to become u, and y cubed dy is going to become 1/4 du. And we get the integral of 2 pi over 3 times 1/4 of the square root of u, or u to the 1/2 du. We still also need to change our bounds. When y equals 0, u equals 1 plus 0 to the fourth, which is 1. And when y equals 2, u equals 1 plus 2 to the fourth, which is 17. Making our integral pi over 6 u to the 1/2 du from 1 to 17. Adding 1 to 1/2, we get 3/2. And dividing by 3/2 is multiplying by 2/3. And now plugging in those bounds, pi over 6 times 2/3 is pi over 9 times, now we have our upper bound of 17 to the 3/2 minus 1 to the 3/2. 17 to the 3/2 is not a number we can evaluate easily by hand. So we're going to leave that as 17 to the 3/2. But 1 to the 3/2 is just 1. So we can get rid of that exponent. And there is the answer to our area of the surface when we revolve our function 3x to the y third about the y-axis.